Hello dear students, welcome back again to study physics, chapter 2, section 2. Today's lesson, it's called solids and their property. We will study in general, what is solid and what is the property of the solid and what is the factor that can affect a solid structure, or how is the molecule that arranged in solid structure. Guys, first, composition of the solid. I highlighted we have 4 points or 4 property. It's written, look, the property of the solid. Guys, as we explained in the previous lesson, we explained it, the first property of solid is definite shape. We said solid have a definite shape, and here is the same version again as solid have a definite shape, which they can preserve. That means what can preserve? For example, any structure of solid, if you apply force on the structure, because as we said, solid is incompressible. We cannot make a pressure on it. That's why they can protect their shape even if you apply a force or pressure on it. They can protect their shape. Second property, are made up of regular array and the atoms of the molecules. Their structure is regular. Look at that this picture. So that one is the structure, atom or molecule. Look, so this is the structure. Just look at it. The molecules, you know, guys. Let me zoom it. Look. That one. This small circle is molecule. Molecule. Look, all this molecule. So all the molecules are arranged so regular, like atom, or they are arranged or next to each other. Look. All the molecules are arranged next to each other. All is regular, so regular. It's not like mixed. The structure is not randomly. All the molecules, look, they are arranged. All they are so arranged, regular their structure. So the structure of the molecules, the second property is important. It's regular. The atoms or the molecules, so regular, arranged. The third property, this particle vibrate around their equilibrium position. They vibrate around their equilibrium position. What that mean? Guys, look, I'm gonna take a small example about this picture. For example, look, we have 2 molecules. These 2 molecules, guys, that 2 molecules, I'm talking about the normal situation without giving them any energy. A normal situation without giving any like kind of energy. These 2 molecules, guys, they are vibration. All time, all the molecules, the solid structure, they are vibrating around this fixed point. Let me make it nice. Just wait. Wait. We have these 2 molecules. This molecule sometimes goes up, sometimes goes down. Why? Because surrounding this fixed position, they are vibrate, go up, go down, go up, go down, go up, go down. So that means the molecules, they are vibrating around this fixed position. So look, around their equilibrium position or fixed position, this particle or these atoms are vibrate, go up, go down, go up, go down. But we have like small vibration, like not the vibration, not quickly, it's not fast. You know why? Because I'm talking about the normal situation without giving them any energy. In normal situation, the atoms or the molecules just they are vibrating around the equilibrium position normally, not quickly. Even it's written here, look. The amplitude of their vibrations, however, very small compared to the distance. It means it's so like you have vibration, but their vibration is so small. Even we can't compare by the distance because we say the distance between the molecules of the solid, they are so small. So we can't compare by the distance. Their vibration of the atom is so small. That's why, because even I told you again, without give them energy, that's why it's small vibration. Even if you give the molecules energy, it's gonna vibrate so fast. So first solid have definite shape and their structure is regular. They have the particles vibrates, and the last one, their vibration is small. Guys, we have the second question. Uh, what are the factors that the arrangement of molecules in materials depends on? We have some factors. We have some factors that can affect the structure of this molecule solid. Look, it's so orange, right? So you have some factors can affect this structure. Some factors. First, shape of the molecules. Guys, each shape of the molecule, they have a different structure. So of course, the arrangement of the molecule is changed according or is dependent the structure of the materials. The second one, the magnitude of the interatomic force attraction. Guys, how we study the type of the force, attraction and repulsion. The attraction force that you have between the molecules, of course, is kind of affect the structure factor too, because how is the magnitude of the force between the molecule? Is it large? Is it small? Or how is the force? How is the type? How is going on? So of course, this force can affect the structure too. The most common important factor is temperature and stress, because if you remember, we studied if we have an ice, it's solid ice. If we give them a small thermal energy, it's changed to liquid. It's gonna be melting directly. So we can, because by give them heat, their structure will be changed, convert to liquid. So of course, temperature is the main factor kind of affect the structure of the solid. Stress too is a mechanical stress or pressure stress. If you apply, guys, as I told you, we cannot even make a pressure on the solid. But what if you apply a large pressure? Maybe it's gonna be damage the structure of the solid. So of course, can affect the structure of the solid. So it's four factors kind of affect the shape and the temperature and the type of the force, atomic force attraction, and even the stress. We have another example. It's same now. I said, by what factors does the composition or the structure of the solid will be changed or vary? Of course, guys, I had the main one, the common one. It's just temperature and stress. Because as I told you, if you give a temperature to a solid state, it's gonna be liquid. Even stress too. If you have this solid, if you apply a large stress or in all direction to this solid, of course, maybe it's gonna be broke or their structures will be changed because you're gonna apply a large pressure on this solid structure. Guys, we have a topic. It's called a rigid body. Rigid body, guys, a body that preserves its shape when forces are applied on it. We have any object, for example, again square. I would like to apply force or this structure or this object. When you apply the force, if this subject, this body, they have or they can ability to preserve or to protect their shape even after you apply the force or after it's going under the pressure, under the force, if they have ability to protect their shape, so this is called a rigid body. Otherwise, no, it's not a rigid body. For example, so I'm gonna apply force. After apply force, still it's square. So like their shape is still square, or still it's an object, like any object is still without changing. So this is a rigid body. What do we have? What do we have? Another example. We have against any object. I'm gonna apply pressure. After a while, it's gonna be broke. I make it two part because after apply force, it's gonna be broke. So that's mean they don't have ability to protect their shape because I applied the force and it's gonna broken the objects. So they cannot to preserve or protect their shape after applying force. This is not rigid body. Guys, in book we have some notes important. All rigid body are solid, but not all solid are rigid. We can, for example, change the shape of the amount of the sugar in back and directions given for sugar solid but it's not rigid. Guys, look at this example. We have a glass. We have a glass. We have this glass. I'm gonna apply a small sugar. Sugar is like a square inside this glass. And we know inside the glass we have a water. It's full of water. After a while, still the same glass, but the sugar, you know, if you put the sugar inside the tea, the coffee, the water, like after a while it's gonna be melt, like it's gonna be broken the structure of the sugar, right or no? After 2-3 minutes, directly it's gonna be melting with the tea, with the water, or the structure of the sugar. It will be broke, of course. So look, even it's just not a water without a sugar. So what that mean? This one, that mean sugar, it is not rigid body. It's not rigid because they cannot protect their shape. And after I put it inside the water, immediately it's gonna be broke. Look. So sugar, that's why in here it's written sugar just is solid because it's solid. Sugar is just solid, but not rigid. Because after applying small force, small reaction, small anything, pressure, small pressure, immediately their structure it will be broke. So sugar just solid, not rigid body. So guys, here we can say if any object, if it's rigid, directly it's solid too. But not all solid are rigid. For example, the sugar it's solid, but it's not rigid. But if any object, if it's rigid, directly it's solid too. I hope you understand this topic because it's important. Another part we have elasticity. The students like do mistake or they mix this topic with the rigid body. Guys, elasticity is the ability of the body to restore its original shape after being deformed under applied force. Again, you have an object. If you apply a force on the object, if this object can ability or they can after a while, like after when you apply the force of pressure, if they have ability after a while to come back or to return back to the original shape, so this elasticity. Otherwise, not elasticity. For example, guys, the best example of this topic is spring. Look, you have this example, guys. Just look at this picture now you understand. So easy. Guys, we have this spring. It's a normal spring without applying. I didn't apply any force on it. Just we have a spring, normal spring. This is called M. M, it means any object, anything, square object, any mass. We have spring, we have an object. I didn't even put anything. Just we have this object and you have this spring. After a while, I put this spring. I put this object on the spring. It's like that. I make a force. I apply this object on this spring. Look, the structure. What's gonna be happening? I'm gonna apply. I apply this object on this spring. Look, it's like compressed. Like I'm gonna apply the force on this springs. The structure it's compressed together. Look, the structure to change. It's gonna be so small compared to the original one. This is the original structure of the spring, but that one after applying the force, look, the structure is changed. Then after picked up this object, remove it, it's returned back to the original shape. Look, still it's like the first one, still it's spring. So spring is called elasticity because in here the third picture, they return back to the original shape. Look, they return back to the original shape without even changing, without even breaking the structure of the spring. Guys, I'm gonna repeat again. Look, we have a spring without put anything, any mass, any object on the spring. A normal spring with just a normal object, or any mass. After a while, I would like to put this mass on this spring. Look, the structure is like compressed. You know, it's like what? If you have a spring, if you'd like to compress this spring, apply force in both directions. You compress it. The structure is gonna be so small like that. After when you apply the force. So this is same. Applying force on this spring, the structure is changed. It will be so smooth. Apply the object. After a while, remove this object. Pick it up. This springs, it's returned back to the original shape. So that means spring is elasticity. So any object, if you apply force on it, if they have ability to return back, so this is spring. Guys, in book you have an example. A certain sleeping matrix is elasticity. Sleeping matrix is the thing that you are sleeping on it when you go to your rooms, your beds. When you are sleeping on this sleeping matrix. When tomorrow you wake up, you know that the shape of the sleeping matrix came back to the original shape. So sleeping matrix is same. And we have another example, guys. For example, sponge. Sponge. When you squeeze it or leave it, then they return back to the original shape. So important to understand elasticity. After applying force, they have ability to return back to the original shape. Guys, we have another type. It's called tension. Guys, in solid state of matter, force all time, the force is called tension. In this topic from now, if you have force, this force is called tension. So you have two types of tension. One of them by stretching and the other by compressing. How? Look, we have this example. It's a spring. Guys, now it's spring. I would like to apply force on the spring. By two ways we can apply force on this spring. First one, it's called stretching. Stretching direction is like that. One of them from the right is T force from the right. The other is from the left. So just look at this picture. We applied two force in opposite direction. So the first T is from the right. The other T is from the left. So that means the type of the force that already we applied on this spring is stretching. Why stretching? Because the T from the right, the other T from the left, it's opposite direction. Like one of them you stretch from the right, the other from the left. So the shape of the spring will be large because you stretch in both sides. So if the T is from the right, the other T from the left, this is called stretching. What about compressing? Same. We have spring. Look, we have spring, same spring. But now I would like to apply force in another direction. This force, like both sides from that direction. T, I'm gonna apply force in that direction. So when you apply, so this is called compressing. The other one, this one is tension, but this one is compressing. After, when I compress this spring, the structure is gonna be small, just like that, because I'm gonna apply force at the end of two springs in that direction. TT, this is compressing. So in general, tension, it's written by stretching or compressing. Stretch, as I said, the T is opposite direction. Wait a minute. Guys, so look. Which type of the force that you have in this picture? Of course, stretching. Why? Because the direction from the left, the other from the right. Look, tension, so this is stretching. What if you have like that? Both T. It's like a mirror. Look, guys. The direction of the T is like a mirror. Both of them is in front of each other, so this is compressing. Okay. So guys, now you understand tension is a type of the force that we can apply on any state of the matter by two ways, stretching and compressing. Guys, you have two types of stress. But before this, let me tell you what the meaning of stress. What is the meaning of stress? Guys, stress, we have a rule. Stress first. Let me tell you the rule. The symbol of the rule, it's like a zero and make a small line equal to, this is called stress, equal to fraction T over area. So this is called stress, and this A is called area, and this T is called tension. Guys, this rule is so important because even you have example to solve the calculation. So this is stress, that one area, the other is tension. So stress is equal to tension over area, is the relation between tension and area. What is the unit of stress? Guys, by the rule, we can get the unit of stress. What was the unit of T? We know, guys, T is force, so the unit of force is N, Newton. What was the unit of area? Area is meter square. So the unit of stress is Newton over meter square. So guys, you have to memorize the rule. Stress equal to tension over area, and this is the unit. And even the definition important. Look, guys, even definition by the rule is you can understand. Stress is the force applied. Is the force. Look, force apply on what? Unit area of the cross section of wire. يعني it's tension T force over area. Look, of course. Guys, you know I said. Look, the rule important. Tension over area. The unit we say Newton over meter square. Guys, stress depends on what? Guys, just look, the definition, unit, factor, or depends on what? By the rule, guys, you can decide that you have how many factors. Look, stress is equal to what? Tension over area. So what factor that can affect it? We have some factors that can affect stress. Of course, tension and area. So stress, يعني this symbol stress is depends on what? Depends on tension and area. Tension and area. Okay, guys, we have two type of stress. Look, be with me. We have two type of stress. First type, we have it's called tensile stress or compressive stress. Same meaning, both of them. It's same name. Tensile stress or compressive stress. The other one is shear stress. So two type of stress. Tensile stress and shear stress. Now even you have to study the difference between them. What is tensile stress and what is shear stress? Guys, both of them is stress, so be careful. Stress, both of them is for tension over area, both of them, but we have some difference between them. Tensile and shear stress. Guys, look, we have this picture. This picture is an example of tensile stress. Let me tell you why. Guys, I would like to zoom it to understand. Guys, look, Bob. At the end, this is wire. Look, at the end of this wire, we have two area, two cross section. One and two. So look, we have two area at the end of each wire. I'm gonna take just this area, this space, and I'm gonna make draw it in here. Look, this is the area of this circle, this section of the wire. Look, Baba, we have this small area at the end of each wire. Guys, when I'm gonna apply the tension of this area, because as I told you, as I said, what is stress? Stress is equal to tension over area. When I'll apply the tension, for example, in that direction, tension T in that direction over this area. As I told you, what is stress? Tension, tension over what? Over this area, over this area. So I'm gonna apply tension over this area. Then, guys, this is A. The direction of the A. The direction of the A is from the up. So look, guys, the angle between the tension and the area is 90 degree. 90 degree, because the angle between tension and area is 90 degree. So that means this type is called tensile stress or compressive stress. That means the angle between T and A is perpendicular. It's called perpendicular. Look, tensile stress or compressive, because the applied force, sorry, this one, this T, wait, this T, the applied force T, this T over this area, this T is perpendicular. That means the angle is 90 degree with this area, because we see the direction of the area from the up. So look, the angle between the area and the T is 90 degree. So that's why it's called perpendicular and tensile stress. So guys, if the angle is 19 degree between the force and the area cross section is tensile stress or compressive stress. We have another type, it's called shear stress. Look, that one, the applied force is tangent to the cross-section area, is not perpendicular. How we know? Because look, guys, we have this object. I'm going to apply the force on the edge of the surface in here. I'm going to apply for this direction or that direction is not important. Imagine I'm going to apply the force in that direction. So this force, this tension, just is intersect the surface of this object, the surface. The applying force is intersect the surface of the object. This surface. The applying force is intersect the surface of the object. Intersect this surface of the object alone. The direction of the T comes on the surface of the object. So this is called shear stress because the applying force, the direction of the applying force is tangent direction of the area. This is called tangent. Tangent means the direction is on the surface on the object. So this is called shear stress. So we have two types, tensile stress or compressive stress. The direction is perpendicular, but shear stress is tangent direction. Okay, guys, so we have another topic. It's called strain. Guys, sorry, it's called Hooke's law. Hooke's law. Guys, this is the rule of Hooke's law. Look, let me show you the rules. Hooke T equal to K bracket L minus L naught. Guys, wait a minute. L minus L naught. Because there is no space. Wait a minute. Okay. Guys, we know now, from now we know T is tension. So L minus L naught, this is called elongation. Elongation, there is no space, so this elongation, okay? Elongation, in here it's written. L minus L naught, elongation of the spring or any wire, any metal. What that elongation? Guys, when you have a spring, when you have, look, for example, in here, I'm gonna make a picture. When you have, or a metal, when you have that metal, we know the original length, for example, L naught, the original, for example, any number, for example, 6 meters. But I'm gonna apply tension. I would like to apply tension T in that direction, and this is to tension in that direction. So which type of tension this? Because in opposite direction, we said T from that direction, it's called compress. I'm going to compress this metal. So when during you compress it, of course the structure of the metal or the spring, it will be changed. It's going to be small because we compressed in this direction. We compress it. So the structure, it will be changed and it's going to be small. So after when you apply the force on the metal and its spring, this changing in length, it's called L minus L naught. After you apply force on any metal, spring, wire, anything, after you apply force, this changing in length in metal, in spring, anything, it's called elongation. Guys, so now we have a relation. Between let me tell you, we have a relation between tension and L minus L naught. T is tension, but the relation with T with L minus L naught is directly proportional. What that mean? If we apply a large tension on the wire, at the end we have a large elongation, large change in length. If we apply a small, for example, large tension, large elongation. What if we apply a small tension, the result you have a small changing in length. So the relation between T tension L minus L naught is directly proportional. That means both of them at the same time is going to be increased, or both of them at the same time is going to be decreased. What is the meaning of K? K, it's called rigidity constant. So the unit is Newton over M. Rigidity constant. So guys, this is really important. We have Hooke proved in the 17th century that the tension of the spring is directly proportional to elongation. As I told you now, same thing. T with L minus L naught directly proportional. That means if T increase, L minus L naught increase too. If T decrease, L minus L naught decrease too. Even guys, by the graph we have look the relation between T and L minus L naught. You have a straight line. Why is it straight line? Because T with L naught is directly proportional. Both of them at the same time is gonna be increased as it goes up. Both of them, the relation is proportional. Both of them it will be increased, or both of them is gonna be decreased. That's why. Guys, we have this question: when a metallic wire is under tension, its elongation depends on what? Guys, when you have this wire, I'm gonna apply tension on this wire. I said that the length of the wire, when you apply the tension T, it will be changed. So this changing in length, this elongation, depends on what when you apply the force. Of course, it depends on the tension, because maybe you'll apply a large T. You apply a large force of T. Of course, the elongation is gonna be so like this, totally will be changed because you apply a large T. And we say the relation between T and elongation is directly proportional. So of course it depends on the tension. The second one, length of the wire. How is the original length of the wire? Is it large? Is it small? Is it short? The third one, the type of the material. How is the type of the material of the spring? Is it good? Because maybe you have sometimes of the material is not good. After applying a little tension, it's gonna be broke directly. How is the structure? How is the type of the material? The fourth one, cross-section wire. يعني the area, this area. This area depends on this area too. If this area is small or large, so the area is factor 2. So guys, in general, this four factor important after when you apply the force on the wire. After, of course, the length of the wire spring, it will be changed. So this change in length, this elongation, it depends on what? The type of the force. Is it large? Is it small? The length of the wire, original. The type of the material. Is it good? The area of the wire too. Guys, last thing we have in here, we have another topic. It's called strain. Guys, this is the rule of strain. This is the symbol of strain, equal to L minus L naught over L naught. Now we said L minus L naught is elongation. So elongation per initial length or original length. So what is strain? It's elongation, يعني L minus L naught per unit length, per this length. Elongation per unit length. So this is called strain. Guys, you have a note. Look, we know L minus L naught is the elongation of the wire, and L naught is initial, the original length. Notice that this strain is unitless. What that mean, unitless? That mean strain, there is no unit. Let me show you why there is no unit. Strain equal to L minus L naught over L naught. Why there is no unit? Strain is unitless. Because unit of L minus L naught is measured by one parameter. So the unit of L minus L naught is just meter. And the down still we have, and again it's length, initial length. The unit of length, this one too, is same as meter. يعني the up is meter, the down is meter. So meter together, because same unit will be cancelled. So no unit is left. Because L minus L naught, it's just meter, and L naught is meter too. So meter will be cancelled. No unit is left. Uh, Guys, today it's enough. For the second video, we will start to study a young modulus. I have to understand to get the benefit from my video all day. Thank you for watching my video. Thank you for subscribing. Thank you for supporting me. Have a nice day.